So the next two problems are involving absolute value, they're equations. And the thing I want to remind you of is this look inside method. So if you take a look at this, right, the 4x plus 8, if I'm taking the absolute value of that expression, it has to be the case that 4x plus 8 is either equal to 24 or it has to equal negative 24. So the 4x plus 8 is either positive 24 or negative 24, because remember, if I take the absolute value of 24, I get 24. And if I take the absolute value of negative 24, I also get 24. So those two values are what the thing inside has to be, 4x plus 8. So if I use this method, this allows me to eliminate the absolute value part and just write two equations that are equivalent to it. So this is equivalent to 4x plus 8 is either equal to negative 24 or the 4x plus 8 is equal to positive 24. Again, because when I take the absolute value of negative 24, I get 24, and when I take the absolute value of 24, I also get 24. Now, there's the same exact two steps, right? I'm going to subtract 8 from both sides and then divide by 4. When I subtract 8 from both sides here, this gives me the 4x, and that's going to equal negative 32. And then over here, when I subtract 8 from both sides, I'm going to get 4x, and then that will equal a positive 16. So negative 32 divided by 4 is equal to negative 8. So x is either the number negative 8, or if I divide 16 by 4, I have x is equal to 4. So the two values that x can be is x can be negative 8 or x can be positive 4. When I plug those values into the expression 4x plus 8, I produce two different things that have an absolute value of positive 24. Let's take a look at the second example I have here. Again, the expression inside 5x minus 7 is either negative 32 or it's positive 32. So 5x minus 7 is either equal to negative 32 or the expression 5x minus 7 equals positive 32. Again, each side I'm going to add 7. So 5x is equal to 7, negative, I'm adding 7. So let's see, negative 32 plus 7 should be a negative 25. Or if I add 7 here, that would be, oh my gosh, 7, 8, 9, it would be positive 39. So 5x is equal to positive 39. If I divide by both sides by 5 now here, in the one case I have x is equal to negative 5, or in the other case I have x equals positive 39 fifths. Again, if I plug that expression into those values of x, if I plug these values of x into the expression 5x minus 7, I will either get negative 32 or I will get positive 32. Both of those values make this equation true. And the last thing I want to point out is that if you're using this technique, right, the look inside method, you need to isolate the absolute value portion of the equation first. So if I'm looking here, I can't say that, hey, that equals positive 80 or that equals negative 80, because it doesn't, right? What I have to do is I have to treat the absolute value of 2x minus 1 kind of like a super variable and solve for that first, get that alone, and then I can use the techniques we just discussed. So in this case, if I subtracted 5 from both sides, I would have 3 times the absolute value of 2x minus 1, and I'm subtracting 5, so that would be 75 on this side. And now if I divide both sides by 5, I have the absolute value of 2x minus 1 is equal to positive 25. And then again, there's two values that produce a absolute value of 25, either negative 25 or positive 25. So either 2x minus 1 is negative 25 or 2x minus 1 is positive 25. And again, same two steps. I'm going to add 1. So that's negative 24. Over here, I'll add 1. And on this side, I'll divide by 2. X is negative 12. And here I'll divide by 2. x is positive 13. So the two values that will work in the original equation are negative 12 and positive 13.